Hello class, today we're going to go ahead and look at section 7.3, square root functions and inequalities. So the first thing we're going to do is we're going to consider the function f of x is equal to x squared. What we want to do is we want to go ahead and we want to graph f of x equals x squared, and then we're also going to graph the inverse. Okay, so let's just start out, let's find the inverse. So remember, to find the inverse, we go ahead and we switch the x and the y values, and we write f of x, and it's all of this squared. And I would think, well, how do I get rid of a square? Well, I would take the square root on both sides, so those will cancel. So f inverse of x is equal to the square root of x. Okay, so that is our inverse. So now I want to go ahead and graph both functions. Well, let's graph our f of x is equal to x squared. You should know that that's going to be a parabola. If I plug in 0, I will get out 0. If I plug in 1, 1 squared is 1. If I plug in negative 1, negative 1 squared is 1. Okay, plug in 2, I get 4. If I plug in negative 2, I also get 4. And I do not think 3 squared will give me 9, so that will not fit on the graph. So here is f of x is equal to x squared. Now we're going to go ahead and graph the inverse function. Well, the square root of 0 is 0. Okay. The square root of 1, so if I plug in 1, I get out 1. Square root of 2 is not a nice value, so let's just try 4. If I plug in 4, so my x value is 4. The square root of 4 is 2. So there is, there is my inverse function. Okay, so this is f inverse of x is equal to the square root of x. Okay. So there's our inverse function. So there they are, both graphed. If you look at them, okay, if you were to ignore this left-hand part, you should notice that the two are symmetric. Or at least if I were to flip them, they would be the same. Because to be symmetric, remember, they go across the line y equals x, just to remind you. Okay, so there they are. And our inverse, that is our square root function. So today we're going to be graphing the square root function. So I just want you to see what the square root function looks like graphed. One thing is, why is there not any values to the left over here? Well, can you take the square root of a negative? You can, but it gives you non-real solutions, so we do not graph them on this coordinate plane. Okay. So let's go ahead and just graph a square root function. Sorry, the smart notebook is thinking. There we go. So we want to graph y equals the square root of x plus 2. State the domain, the range, and the x and y intercepts. So let's just go ahead and start filling in our table. If I plug in negative 3 plus 2 is negative 1. The square root of negative 1 is undefined, so you'd say undefined, or it's a non-real answer. If I plug in negative 2 plus 2 is 0. The square root of 0 is 0. Negative 1 plus 2, well, that gives me 1. The square root of 1 is 1. 0, well, that would give me 0 plus 2, square root, so it gives me the square root of 2. And if I type that into my calculator, I get it's approximately 1.414. And 1, okay, if I plug in 1 plus 2 is 3, so I get the square root of 3. So that is approximately 1.732. So let's go ahead and graph this. So at negative 3, it's undefined, so I don't graph anything. At negative 2, it is 0. I have negative 1, 1. I have this 0 and the square root of 2, so 0, 1.414. Okay, 1, the square root of 3. So it looks something like this. So here is my square root of x plus 2. So now we need to go ahead and we need to say, well, what was the x-intercept, the y-intercept, the domain, and the range? So the x-intercept, remember the x-intercept. This is when our y is equal to 0. Okay, so if I look at when y is 0, this is, remember, your x-axis, this is your y. So if y is 0, it's right here, or where it hits your x-axis, and so my x value here is negative 2. And if I wanted to write it as an ordered pair, I'd write -2, 0. Now my y-intercept, that's where it hits the y-axis. Remember, that's when your x is 0. Okay, so when my x value is equal to 0. So if I look at that, it'd be this point right here, and when we plugged in 0, we got out the square root of 2. So that it's the square root of 2, and if I wanted to write it once again as an ordered pair, it'd be 0 square root of 2. The domain. Recall the domain is your x values, and the range is your y values. Okay, so domain, I'm looking for my x values. Well, if I look, this is -2, and then they go all the way to the right. So it's when x is bigger than -2. So what we say is when x is greater than or equal to -2. Okay? Algebraically, we can look at where this came from. If you look at our equation, it was the square root of x plus 2. Well, I know that when I take a square root, this has to be either 0 or bigger than 0. So one way to find your domain is to take what's underneath the square root sign and say it has to be greater than or equal to 0, and then solve. X is greater than or equal to -2. That is what we got down here. Okay. Range, then, that's your y values, and if you look at that, for this case, my y values, starting here and goes up. Okay, it's going to go up. So it's when y is, well, what's your lowest y value? Well, it's greater than or equal to 0. So math rules to live by. Okay, so you're going to have to make sure you keep thinking about these throughout the entire chapter. So can't divide by 0. Same thing as having 0 on the denominator. Can't take the square root of a negative number. Can't have negative exponents in your simplified answer. Can't have radicals in the denominator. So just in case you don't remember that one. If I have the square root of x, can't have that. Can't have the square root in the denominator, the radical. And you can't have fractional exponents in the denominator. Okay. So what they were going to talk about here is how to find the domain of a square root function. Okay. The radicand has to be greater than or equal to 0. So this is what I was talking to you about. So this part, what's underneath the square root sign or the radicand, has to be greater than or equal to 0. Okay. So in order to find the domain, I would say, well, 4x plus 2 has to be greater than or equal to 0. So I would subtract 2. So I have -2, divide by 4. So my domain in this case is that x is greater than or equal to -2 over 4, which is -1/2. That is my domain. Okay. If I go ahead and take a look at the other one, to find the domain, I'm going to do the same thing. What's underneath the square root sign of the radicand? So it's 2x minus 3 is greater than or equal to 0. Add 3. So x is greater than or equal to, I divide both sides by 2, 3 over 2, or 1.5. So my domain in this situation is x is greater than or equal to 3 over 2. Okay, so that's how you're going to find the domain of a square root function. The next thing you need to talk about is how to find the range. Okay. You just look at the number after the radicand. Okay. So in this case, the number after the radicand or after the square root sign is your plus c. Okay. So my domain for this one would be when y is greater than or equal to c. What if it's not there? Okay. If there's no number after the radicand, then the range is y is greater than or equal to 0. And if there is a number, then the range is y is greater than or equal to that number. So if I look at the example that I had before, the way that I could really rewrite this is plus 0. So my domain, or sorry, excuse me, my range would be, well, I have the domain from the front side. Sorry, my range then would be y is greater than or equal to 0, since there is no number there. Then if I go ahead and look at the next one, which we did before, we got that it was the domain is greater than or equal to 3 over 2. The range for this one would be, well, this is my c value, so y is greater than or equal to 4. So that is the domain and the range for the square root functions. So now we're going to use this information to graph it. So we want to state the domain, the range, and the x and the y-intercepts. So let's just go ahead and find all of those things and then graph from there. Okay. First thing let's find is the domain. So I take whatever's underneath the square root sign, say it's greater than or equal to 0, divide by -2. So x is greater than or equal to 0. But what did I forget to do? I remembered that when I divide by a negative or multiply by a negative, the sign must flip. So really, my domain is x is less than or equal to 0. Okay, so that is my domain. My range, guess I really don't have to do much work. It's whatever's after the square root or the radicand. So in this case, it's y is greater than or equal to 3. So greater than or equal to 3. And then now I need to find my x and my y-intercept. Well, remember, you always find your x-intercept by letting y be 0. So I'm going to plug in 0 for y and solve for x. So I would subtract 3. To get rid of my square root sign, I would square both sides. So this gives me 9 is equal to -2x. Then I will go ahead and divide by -2. So x is equal to -9 over 2. Okay. So my x-intercept is -9 over 2, and it's when y was 0. My y-intercept, that's when I let x be 0. So I plug 0 in for x, so I would have y is equal to the square root of -2 times 0 plus 3. -2 times 0 is 0, so that is 0. Y equals 3. So it was x was 0 and y was 3. Okay, so I can use this information to go ahead and graph my function. My recommendation to you, okay, is use your domain to come up with a table. When I make my table, I start with that value. It says when x is less than or equal to 0. Okay, so I would do 0 and then numbers less than 0. I would think about what I'm going to plug in and what it will give me. I would maybe say, well, 2 times what? Okay, 2 times what gives me something I can take the square root of. I know I can take the square root of 4, so -2 times -2, just an idea. And then you could continue this process if you wanted. I know 16, so I could do times -8. Okay, and then I would plug it in. Well, I know that when I plug in 0 from my y-intercept, I get out 3. If I plug in -2, -2 times -2 is 4. The square root of 4 is 2. 2 plus 3 is 5. And then I would have -8 times -2, which is 16. The square root of 16 is 4. 4 plus 3 is 7. And I would graph these values along with my x-intercept. Okay. So I would have 0, 3, -2, 5, and -8, 7. I don't know if that one's going to fit on here. No, it won't. So I'm going to have something that looks like this. Okay. Oh, and I made a mistake. Because look at this. Will I ever have an x-intercept? I will not ever have an x-intercept. So in this case, this is a none. There will never be an x-intercept. Okay. So let's go ahead and look at the next one. And I'm just going to back up 1 second. The reason I won't have an x-intercept is, do you guys notice when I got to this point right here, I had -3 is equal to the square root of -2 times x. Can I ever take the square root of something and get a -3? No. So I should have stopped right here. So that is why there is none, or there is no x-intercept. Sorry about that. Okay. All right, graphing square root inequalities. So we've done inequalities before. Okay, now we're going to do them with square roots. So a square root inequality can be graphed in a similar way as square root equations. The equation serves as a boundary to the area represented in the inequality. Okay, so some things that we should remember. If we have a less than or greater than sign, it requires a dotted or dashed line. Okay. If it has this equal to on it, less than or equal to or greater than equal to, then it is going to require a solid line. Okay. So one very important thing to remember. And then remember, after we're done, we shade. Okay. So let's go ahead and do an example. So 4 says graph y is less than the square root of 2x minus 6. So what I would do, find the domain and the range, and then let's go from there. So my domain is 2x minus 6 is greater than or equal to 0. Okay, because whatever's underneath my radical. So I would add 6, divide by 2. So x is greater than or equal to 3. That's my domain. Now I would go ahead and find my range. Remember, that's whatever is after the radicand. Well, it's really plus 0, so my range is y is greater than or equal to 0. And now what I would do is find my x and y intercepts. So remember, my x-intercepts, it's when y is equal to 0. And if I would square both sides, I can square 0. 0 squared is 0. So I have 2x minus 6. I would add 6, divide by 2. So I would get 3. Should have had an equal sign for here. We solve it just like an equal. So it's when x is 3. So this is my x-intercept. So it's 3, 0. Okay. My y-intercept. Remember, that's when I let x be 0. So it would be 2 times 0 minus 6. 2 times 0 is 0. 0 minus 6 is negative 6. So this, I have a negative underneath my square root sign, so there is no real solution. It's complex. So there is no y-intercept in this case. Okay, then the last thing I would do is come up with a table to get a few ordered pairs to graph it. So I would start with my domain, which says x is greater than or equal to 3. Okay, so if I plug in 3, I already know that I should get out 0 from my x-intercept. And then I'm going to go ahead and plug in 5. The reason I'm going to plug in 5 is 2 times 5 is 10. 10 minus 6 is 4. The square root of 4 is 2. I'm just trying to get nice, simple answers. So I'm just trying to think about what I could get for an answer. So I would say, well, the next one would be if I could get the inside to be 9. 2 times what minus 6 would give you 9? Well, 7.5, that would give me 15. So 2 times 7.5 is 15. 15 minus 6 is 9. So the square root of 9 is 3. So I'm just kind of getting an idea of how to plot this. So I would have 3, 0, 5, 2, and 7.53. Something like here. Okay. Oh, and this we need to graph. I would notice that it is an inequality. So it's less than, so I need a dotted or dashed line. So it's a dotted line, so I need to make this dotted. Okay, and then it says y is less than. Well, to be less than, I would shade below. Notice I am not shading to the left because my domain does not go to the left of 3. It's only greater than. So there is my inequality graphed. Okay. Example 5, y is greater than or equal to. Now in this case, since it's equal to, it's going to be a solid line. Okay, so I start out doing the same thing that I did before. I would start by finding my domain. Okay, the domain. multiply by 2 on both sides, so x is greater than or equal to 0. So that's my domain. My range is whatever's after the square root sign, so y is greater than or equal to 2. Now I'm going to go ahead and find the x-intercept. Remember, that's when y is 0. So I would have 0 is equal to the square root of 1/2 x plus 2. Subtract 2. Now I have the same problem that I had before. Will I ever take the square root of anything and get a negative out? No, so this means there is no x-intercept. Okay, now I found my y-intercepts. The way I found my y-intercepts, let x equal 0. This will be 0, the square root of 0 is 0, so y is equal to 2. So I have 0, 2. Then I would make my table. I start with my domain. My domain is 0, and it says x is greater than. So I'm for sure just going to do 0, and I plug that in. I already know from here that I get out 2. Now I think, okay, I can take the square root of 1. Okay, if I plug in 1, what would I have to plug in for x to get 1? Well, if I plug in 2, 2 times 1/2 is 1. The square root of 1 is 1. 1 plus 2 is 3. Then the next number I want to get underneath my square root sign would be 4. So what times 1/2 will give me 4? Well, 8 times 1/2 is 4. The square root of 4 is 2. 2 plus 2 is 4. Okay, so let's go ahead and graph this. So I have 0, 2. I have 2, 3. And I have 8, 4. There it is. It should be a solid line. And now it says y is greater than or equal to. So it should be greater, bigger, I think. So I go above, and I shade. Once again, don't forget to remember dotted or solid, and then also to shade above or below. So we're going to look at one last problem. Okay. The speed v of a ball can be determined by the equation. V equals the square root of 2k over m, where k is the kinetic energy in joules and m is the mass of the ball. Assume that the mass of the ball is 5 kilograms. Okay. So I'm just going to think about that. Well, my mass is 5 kilograms, so I'm going to plug that in for m. So there is my speed or velocity. Okay. A says graph the function, state the domain and the range. Okay, so let's go ahead and graph the function on our calculator, because we can also do this on our calculators. So you're going to go to your y equals. Sorry, I'm just trying to get down the screen for you. Okay, go to y equals and type in the equation. It is the square root. So everybody knows the square root is above, it looks like x squared. So you go second square root. And then I want to have 2k in the numerator. So parentheses 2, and in this case, since we're just going to use x, and the parentheses being divided by 5. Notice how all of it is written underneath the square root sign exactly like I would want. So I'm going to go ahead and hit graph. Okay. My window is set to be very large, so I'm going to change that. I'm going to just use standard for right now. So I'm going to go zoom, and then standard's number 6. So that does the -10 to 10, -10 to 10. Okay. So there that is showing there. So there is my speed graphed. It says state the domain and the range. Okay, well it looks like it's starting at the ordered pair 0, 0. So my domain in this case it's greater than the domain, and that's my x value, or in this case it's my k value. So it's when k is greater than or equal to 0. And my range is my y value, or in this case we're getting out v, is greater than or equal to 0. Okay. So there those are graphically, and that's what my graph looks like. Okay. So my domain, once again, was k is greater than or equal to 0. My range is when my velocity is greater than or equal to 0. And you could also have done that from what we did before. My domain, I would say 2k over 5 is greater than or equal to 0. Multiply by 5 on both sides. Divide by 2, so k is greater than or equal to 0. That's exactly what I got for my domain. And then remember, your range is from whatever comes after the radical sign. Well, this is really plus 0, so there you go. And the last part of the problem, it says the ball is traveling 6 meters per second. What is the ball's kinetic energy in joules? So, traveling at 6 meters per second. Well, v is the speed, so that is talking about the speed. So I'm going to plug that in for v. So 6 is equal to the square root of 2k over 5. To get rid of my square root sign, I would square both sides. 6 squared is 36. I would multiply by 5 on both sides. 5 times 36 will give me 180. I would be left with 2k. And then I would divide by 2. So k, which is my kinetic energy, is equal to 90. So my answer is 90 joules. Okay. So there we go. Okay. Make sure that if you have any questions on any of this, you write it down. Ask me tomorrow in class when you have a second. Otherwise, I will see you tomorrow. Have a good day.